Hello and welcome. In today's video we are looking at acids and bases, and we're going to look at how they react together and what sort of substances contain acids and bases. Now, first thing to remember about acids and bases is that they are the opposite of each other, and we can react them together, and when we react them together we can have what we call a neutralization reaction. You might remember a neutralization reaction from a previous video. It's when we react an acid and a base and we make them neutral. It's also an exothermic reaction. So it's an example we gave previously of an exothermic reaction, one that gives out heat energy. But for now we've got acids and bases. They are the opposite of each other, and when you react them together we get neutralization, or they neutralize each other out. A couple of examples of acids would be nitric acid. Another one is hydrochloric, and these are all ones that you should be familiar with, that you've come across in this topic. And the other one is sulfuric. There are obviously lots of other kinds of acid, but these are ones that you should be very familiar with. In terms of bases, what do we mean by bases? Well, all metal hydroxides are bases and all metal oxides are bases. So an example we could give, or something that we've come across for metal oxide, is iron oxide, and another one we've worked with is copper oxide, and these are bases. Now sometimes bases can dissolve in water, and if they dissolve in water we say they are an alkali. So a base that can dissolve in water is called an alkali. So you may have seen these words used interchangeably, but you should know the difference between the two. How can we identify if a substance is an acid or an alkali? Well, we use something else that you're probably quite familiar with, and this is called a pH scale. Small p, capital H, and it's a scale that we can use to find out if a substance is acid or alkali. We add what we call universal indicator. There are other types of indicator, but universal indicator is one of the more common ones. And on this scale we have a scale from 0 up to 14. I've actually just done 1 to 13 here, and right in the middle there we have what's called neutral, and neutral has a pH of 7. Down the end here this would be pH 1, this would be pH 13 over here, and at the end of pH 1 this is a strong acid. At the end, or the side nearer neutral, this would be a weak acid. pH 8 over here just after the 7, that's a weak alkali, and right down the end here this is a strong alkali. Okay, so this is how you use the scale. You can identify how acidic or alkaline something is, and in fact also how strongly acidic or alkaline it is. Now the next thing I want to look at is a reaction between acids and alkalis. So an alkali, remember, is a base that has been dissolved in water, and for these ones I've got here we can see that this one is round about a pH 1, 2, 3, 4, and the alkali is round about pH 13 on my scale there. Okay, so that's how we would use our scale. One thing I want you to be quite carefully aware of is that when we look at acids, if we look around inside the solution, if we were able to magnify it enough, we would see that in the solution we have a lot of what we call hydrogen ions. So these are represented as an H with a little plus next to it. So these are our hydrogen ions, and the reason why an acid is an acid is because it has a number of these hydrogen ions floating around in the solution. We actually say there are hydrogen ions in solution, so we would write it like this. And if you remember from a previous video, AQ means aqueous, and that means they are in a solution. So this identifies this substance as an acid, the fact that there are hydrogen ions swimming around. If we were to look at the alkali and look inside there, you would see that it's not hydrogen ions that are floating around, but what we call hydroxide ions. and that is represented by an O, an H, and a minus, and there's a single minus charge on the OH, and similarly we write that out as OH minus, and we put a little A and a Q to say aqueous. Now we know that if we add an acid to an alkali, we can get a neutralization reaction. How does that exactly work? Well, you have to very carefully mix the acid and the alkali together. In this diagram it looks like I've just sloshed it all in, but you have to be a bit more careful than that, because the point at which it's neutral is a very delicate point, and you have to add the acid or the alkali very carefully. But if we look at the idea behind it, basically we add our acid to our alkali, and we watch to see when the solution goes this neutral color, so it's just about there on our pH scale. Okay, and when we look inside there, what we see actually happening is that the hydrogen ions will react with the hydroxide ions. Remember, it is a reaction, and they will join together to form water. So you can see there we've got an H and an H, so two H's and an O. That gives us H2O, a single plus charge and a single minus charge, so that means they'll attract together and they will form water, which is H2O. And we can write this in the following way. So we can say H plus ions plus OH minus with a little arrow gives us H2O. It's also very important that we write our state symbols, and by our state symbols we mean the symbols to tell us whether this is solid, liquid, gas or aqueous. And in actual fact, for the hydrogen ions we said it was aqueous, put it in brackets, hydroxide, aqueous, sorry I've done that very small, it's a bit annoying. And for water it's a liquid, so we put a little L in brackets. Okay, so this is an important equation that you need to know that represents what we mean by neutralization. Okay, so that's an overview of what we mean by acid and alkali and what we mean by neutralization, and you should be able to talk about concentrations of hydrogen ions and hydroxide ions. Let's write that out. Hydroxide ions, and what happens when we have neutralization. Okay, and the last thing I want to go through really is related to this, but slightly at a tangent. We've got the production of ammonium salts. Now we say it's related because this is making ammonium salts is an example of a neutralization reaction. It's an example of a neutralization reaction, and it works like this. If we take some ammonia, a substance called ammonia, and dissolve it in water, what you end up with is a substance called ammonium hydroxide, and ammonium hydroxide is an alkali. It's an alkali, and we can use this to produce what we call ammonium salts. And the way we do this is, because it's neutralization, we have to react it with an acid. So we've got our alkali here. Let's use some colors. We've got acid here, and the reaction is called neutralization, as we know. And when we carry out this reaction, we get a salt, and this salt in this example is ammonium nitrate. Now ammonium nitrate is a very useful substance because we can evaporate this whole solution down. We can evaporate and crystallize, similarly to as we've done before, as shown before in a previous video. But once we evaporate and crystallize, we have crystals of ammonium nitrate, and these are very, very useful for fertilizer. So we have an ammonium salt, and we use those as fertilizer. And the reason why they are so important is because they contain, ammonium contains a very important element called nitrogen. So nitrogen is found within the compound, and this is very important because it's required for growth. In actual fact, if you want to be really clever about it, it's required to make amino acids. Amino acids have nitrogen in their structure. These are required to make protein, and protein is required for growth. So that's the actual, technically, why that nitrogen is so important. And so if we have an ammonium salt which contains the element nitrogen, we can use that as a fertilizer to help plants grow. And the last thing I want to briefly mention, which I forgot to show you, is that when we have ammonium hydroxide in a solution, we have OH minus ions, hydroxide ions, and we have ammonia. So the OH minus is what causes the substance to be alkaline. Okay, so we've talked about acid and alkali, what we mean by those two terms. We've talked about neutralization reactions, and we've given an example of a useful neutralization reaction, which is on this page, and that's to make ammonium salts, and those are so important because they make fertilizer. Other than that, the rest is you just reading around a bit, making sure you understand this topic. Go over the video one or two times if you need to, but that's me done for today. Thanks for watching, and I'll see you again soon.